In this lecture, we are going to deal with push-down automata, which is nothing but automata for context-free languages. We have automata for regular languages is finite automata. The same way we have automata for context-free languages is push-down automata. This push-down automata is simply using an equation. You can simply define that it is nothing but a epsilon NFA plus a stack. This is the addition that we have to the corresponding finite automata. You got my point? Here the stack acts as a memory where we can able to remember some of the contents of the corresponding string. That enables us to remember the contents of the string. This push down automata can be represented by using a 7 tuple value, where we have in earlier finite automata we have 5 tuple value. In addition to that one, we have two more symbols are there. Those two more symbols are related to stack itself. One is tau, set of stack symbols, and the next one is z0, initial stack symbol. These are the addition to the whatever the finite automata that we already gone through in PDA. Okay, same way we have the corresponding delta function. This is the transition function. This transition function is nothing but whatever the transition from one state to another state that we generally do. Here the corresponding transition state can be represented as q cross sigma cross tau gives rise q cross tau. For example, here is a picturistic representation from qi to qj transition. This is the current state and this is the next state. This is the input symbol. A is the input symbol over here, and x is the top of the current top of the stack. You got my point? In stack we have operations called push and pop, and there is a thing called top where we can able to perform insertion and deletion only at the end. That is going to be called as top. This is the top of the stack symbol. This y is the whatever the top of the stack symbol after doing some operation on the stack. Those operations may be a push and or a pop or do nothing. Sometimes what we do that we will just we do nothing. That means we will just there is no push and there is no pop operation. There is no change in the corresponding stack symbols. You got my point? This is a simple representation. You can see that. Of course, in a given example, you can see that from Q0 to Q1, this is the input stack symbol. Input tape symbol. This is the input tape symbol. And this is the top of the stack. This is the top of the stack. That means we do nothing over here. You can see that. We can do nothing over here. Same way here also. We do nothing over here. But you can see over here that it is the input tape symbol. This is the top of current top of the stack symbol. After that one we have y. Y is nothing but a z0. That means we are pushing a into the stack. Okay, this is the representation over here. Same way here you can observe that B is the input tape symbol, Z0 is the corresponding top of the stack symbol, and this is the whatever the thing that we after pushing the stack contents BZ0. That means we pushed B onto the stack. This is the representation over there. You got my point? Stack, whatever the push down the automata that we are already going through, can be simply represented by using this diagram. We have input tape, we have some finite control, and we have some stack. Three contents are there: input tape, finite control, and stack. In earlier finite automata, we have only two things over there: input tape and finite control. But now, in addition to those two things, we have stack. Whatever the stack that we have in push down automata, that is unlimited, unbounded, unlimited memory. Whatever the input tape that we deal with generally, that is some way somewhat limited. That means limited in terms of the tape is only for input only. You got my point? The tape, the purpose of tape is only for input, giving the input to the finite control. You got my point? Okay, this is the simple abstract view of push down automata. You can see that, for example, for a to the power of n, b to the power of n, this is the starting symbol q naught. What we have to, keep on while doing PDA, what we have to do is, when we have first we have to start with a q naught state, and after that one what we have to do is, when we have to change the state, this is the decision that we have to take at our end. You got my point? When we have to change the state, when we have to go for the final state. Actually, in push down automata, we have two types of acceptancy. The one generally we adopt is final state acceptancy, which we already gone through in finite automata, in earlier finite automata. The same way we have final state, which is represented with double arrow, double circle. You got my point? Whereas we have another acceptancy called empty stack acceptancy. That means based on the symbols in the stack, we can say that the corresponding string is accepted. We can say that the corresponding string is accepted. Generally, until unless it is explicitly mentioned to write the empty stack acceptancy, we generally go for final state acceptancy that we already gone through in finite automata. You got my point? What are the examples that generally I deal with in this lecture is completely related to final state acceptancy. Final state acceptancy. You got my point? You can see that whatever the final state acceptancy in various examples that I have gone through, the same transition is there, and one more state to the whatever the entire earlier PDA, and one more extra state over there by using the transition called epsilon. You got my point? Z0, Z0. That means by taking the whatever the end of the string is epsilon, and top of the symbol stack is Z0. That means no contents are there in the stack except initial stack symbol, and we do nothing over here. We are not dealing with the empty stack acceptancy. This is the standard transition for the empty for the corresponding final state acceptancy. You got my point? You can see that in every example, epsilon Z0 Z0 final state, epsilon Z0 Z0 final state. You got my point? Okay, we will go through the first example, a to the power of n, b to the power of n. Earlier in finite automata, generally we take a minimum string, and based on that one we do. What we do in for the PDA is that we will take a not minimum string. Very, very important point. We don't take any minimum string in to construct the PDA. But whereas in finite automata, we generally go for the minimum string first, and after that one we will add some more. You got my point? But in PDA we will take not minimum, but the next one and the after next one, whatever the string that is generated from the given language. For example, I am taking double A, double B, AA, BB. This is the stack that I am representing over there. Okay, in exam also you have to represent like this, so that we know that you constructed the whatever the problem in a using a correct procedure. You got my point? This is the first symbol that we are going to process, A. The initial stack symbol is Z0. After processing the A, Z0, the corresponding stack symbols are A Z naught. Actually, it should be A Z naught, not Z naught A. You got my point? A Z naught. You got my point? Next one, what we have is next A. Actually, what we have to do is while doing PDA, we have to decide the logic. That means we have a stack over there, and what logic that we have to adopt. For that one, here the logic is for every A we push onto the stack, and for every B we pop the corresponding A. You got my point? If any A is left out in the stack, that means after processing the B also, all the B's, any A is left out in the stack, that means number of A's are greater. Same way, if any B's are there without top of the stack symbol is A, then obviously number of B's are greater than number of A's. You got my point? Actually, you can simply say that in PDA, when we have to perform the push operation, when we have to perform the pop operation, when we have to change the next state, these are the three things. These are the three things that we have to we have to analyze while constructing the PDA. The first one is when we have to push, when we have to pop, when we have to change the state. When we have to change the state. Regarding this state, changing the state, this is the standard way of changing the state. You got my point? This is the standard way of changing the state. You got my point? For the final state acceptancy, epsilon Z naught Z naught. You got my point? Here the logic is whenever we have A's, we are going to push onto the stack, and whenever we have B's, we are going to pop the corresponding A. For pushing onto the stack, we are going to mention like this. You can see that this is the input A symbol. This is the top of the stack symbol. That means for first A Z naught, top of the stack. For the every other A that we have in A to the power of n, we have this transition. The corresponding A we have double A. That means this double A. That means we have extra symbol on the stack. After processing after the top of the stack, we have AA. That means one more symbol. That means push operation is done. This representation is nothing but a push operation. This means one more symbol. A. Z naught. A Z naught. This should be A Z naught. Same way, when we have to change the state, whenever we are going to encounter the first B, after that one everything is nothing but a B. It should be a B. If at all we are going to encounter A, that means there is no transition. That is why it is stuck over there. That means no final state acceptancy for that one. For B, processing B, this is the top of the stack symbol. You can see that this, whatever the epsilon after that one, that means this is nothing but pop operation. You got my point? You can see that first B, AA is there. After that one only single A is there. You got my point? This is pop operation. This will be repeated as many times. You got my point? This will be repeated as many times that we have B. After, if everything is right, that means the number of A's and number of B's are equal. Then what happens that whatever the number of A's that we push onto the stack is equal to the number of A's that are popped onto the stack by using B is equal. So that there should be like this. You got my point? At the end we have epsilon Z naught, that is nothing but Z naught, which is nothing but final state acceptancy. You got my point? In this way simply we can able to construct a PDA. You got my point? We have another lecture regarding this PDA. Thank you.